Edexcel Core Pure, Hyperbolic Functions 2, Inverse Hyperbolic Functions. Integration using hyperbolic substitutions. So in previous videos we've looked at how substitution can be used as a way to make an integration easier to evaluate. We have seen how trigonometric substitutions can be very effective in simplifying an integral. However, for these examples we're going to be looking at how hyperbolic functions can be used as well. For example, if we have functions of the form the square root of x squared minus a squared, then the substitution x equals a cos u can be used in order to simplify the problem. So in these problems and similar problems, you may find it useful to remember the identities. Cos 2u is 2 sine squared u plus 1, or sine 2u is 2 cos u sine u. So we are going to try and complete the integral of the square root of x squared minus 9 using the substitution x equals a cos u. If we use x equals 3 cos u here, we should be able to take 3 outside the square root eventually in order to be able to simplify the integral. So let's have a look at how this integral would pan out. It's quite a long integral, so I'm going to do it in stages and keep an eye on those identities as well. So we're going to let x equal 3 cos u. Notice 3 squared is 9, which I can see in the problem. So 3 cos u will hopefully be very helpful. If I differentiate that, I get dx by du is 3 sine u, and therefore dx is like a 3 sine u du. So this integral that we're trying to do, which is the square root of x squared minus 9 dx, can now be written as the integral of, so we're looking for the square root of x squared minus 9, which is the square root of x squared is 9 cos squared u before we take away the 9, and dx is 3 sine u du. Notice that 9 is a common factor, so if I pull the 9 out of this square root we get a 3, so it's 3 times the integral of the square root of cos squared u minus 1 times 3 sine u du. So now I'm going to do the 3 times 3 equals 9, and the integral of cos squared u minus 1 is the same as sine squared u, and the square root, so this becomes the square root of sine squared u times another sine u du, which is 9 times the integral. We're square rooting sine squared, which is sine u, and then we're timesing by another sine u, so that's sine squared u du. So we are well on the way to making this integral easier to complete. So the couple of things to look out for here are the sensible substitution of x equals 3 cos u, noting that 3 squared would link nicely with that 9, and that has allowed us to produce a much nicer integral. We've also used the fact that cos squared u minus 1 can be written as sine squared u, which has resulted in this new integral. So now we're going to try to integrate 9 times sine squared u du. So the first thing I'm going to do here is to use an identity. It's the sine squared that's the problem, so I'm going to substitute sine squared u is a half of cos 2u minus 1. So this is 9 over 2 times the integral of cosh 2u minus 1 du, which is 9 over 2. And now we can do this integration. It's sine 2u, but it'll need balancing it with a half, minus u plus c. And if I rewrite the sine 2u, it becomes 9 over 2. The 2's will cancel out and leave cosh u sine u minus u plus c. Now, we're not quite there yet because we remember this is an indefinite integral and we need to be able to substitute back for x. So what do we know at the moment? We know from our substitution that x is 3 cosh u. Therefore, we know what cosh u is. Cosh u is x over 3. So that's going to be helpful. We're going to need cosh u. We also know that sine u is the square root of cosh squared u minus 1. So sine u is the square root of cosh u, which is x over 3. It needs squaring, and then we take away 1. So now we have sine u in terms of x and cosh u in terms of x. So I can write this answer now as 9 over 2 times cosh u, which is x over 3, times sine u, which is the square root of x squared over 9 minus 1, minus u, and u, we can see from here, u is the inverse hyperbolic function of x over 3. So this is take away r cosh x over 3 plus c, and just simplifying this a bit, losing the brackets, I'm also going to pull a 9th out of this square root, so we will end up with a half of x. I'm pulling a 9th out of this square root, so it becomes x squared minus 9 minus 9 over 2 r cosh x over 3 plus c. So we used our double identity to deal with this sine square, to write it in terms of 2u, and then in order to be able to substitute back, we needed to write sine 2u as 2 cosh u sine u, and then based on the original x equals 3 cosh u, we were able to find sine u and u itself. And when we substituted back for x, we simplified things. I also pulled a 9th out of this square root, so it became the square root of x squared minus 9. And that brings us to the end of inverse hyperbolic functions.